And we focus on technologies and developments that keep pushing efficiency. Racks of the next generation are going to be 125 kilowatts. So in general, right, customers really do need to think about, what is their quality, what is the reliability of these products.
This is the podcast for engineers, the podcast you just have to listen to if you're interested in what's going on in the semiconductor market. I'm your host, Kelsey Markle, and today I'm joined by Danny Clavette. He is a distinguished system architecture engineer at Infineon. So, Danny, thank you for being here.
Very nice to be here. Thank you.
Great. So let's jump right in. In previous episodes, we've talked about AI, the increased demand for AI, the stress this is putting on data centers. Let's really just paint a picture though here. What does the data center structure look like?
Okay. Well, first of all, currently there's about 8,500 data centers in the world. There's a roadmap for building another 150 data centers this year. And these data centers, vary in sizes. Companies have their own data centers, like Apple will have their own data center. But the very large what we call hyperscale data centers, they can contain 10,000 racks, and a rack is like a physical unit, a very tall rack system where you put a bunch of servers inside, right? So
okay, like the big cabinets that you imagine whenever you imagine a data center.
Imagine a big warehouse-sized building with 10,000 of these things. The largest data centers get up to 40,000 of these racks, and so these racks kind of carry a bulk of the workload, a bulk of the processing power, and then in these racks, you'll typically have about 24 AI processors and about 50 CPUs, right, in one rack. And so if you do the math, 10,000 racks times 24 AI processors, that's 240,000 AI processors and 500,000 CPUs. In a 10K rack data center. So these are big numbers, right?
Yeah, and it really adds up. So even the small components really multiply
Right.
and amplify.
And what AI is bringing to the rack level is the power in each rack is going up substantially, right? The racks today are in the order of like 16 kilowatts. Racks of the next generation are going to be 125 kilowatts. And this is driven by AI compute power and the insatiable appetite for AI data and learning and generative AI also.
Yeah, nearly everything has some sort of AI feature or is supported by AI nowadays. So I can see this just exponentially increasing. If we look at Infineon, you painted a really beautiful picture of a data center. If we think about Infineon, where does Infineon fit into this picture?
Yeah, very good. So in the data center itself, where Infineon takes care from AC/DC all the way down to the processor. I work with team members that work on taking the high voltage AC and stepping it down to the rack. And then in the rack level, we further step that AC voltage down to like a 48 volt backplane. There's a lot of components for Infineon. It's very, very good business. It's good that the power is going up. And then once you get inside the rack, each tray that goes in, each server tray, that's where the processors are held. And inside these trays, this is where I work. We deliver power to the processor. So if you ever see a picture of a processor online, you'll see a bunch of little rectangles directly around it. Right, and these little rectangles are us. It's Infineon, so it's very, very good business for us. And what we're doing when we're on the processor is we have two key components that we work on, at least in the multi-phase side. So we have the brain, which we call the digital controller, and this digital controller is an IC that we develop, and we communicate to the processor, and the processor tells us what voltages it wants, what type of, how much energy is it going to consume. We provided telemetry information, temperature, current information, system health information. So that's one piece, the brain. And typically, this is a 7 by 7 millimeter device, right? And then the brawn is what we call power stages. These are little, tiny little 4 by 6 power stages. They can support up to 90 amps a piece. And just to put in perspective, in the US, the circuit breaker on a house is about 100 amps, right? So this tiny little device, right, can support up to 100 amps. And what we do is we take these devices, we can scale them. We can put a bunch of these little devices, and they work in unison, kind of interleaved, right? So they all fire at a different time, kind of like cylinders in a car, right? And we deliver the power to the processor with these power stages. And
Okay,
in
so
these power
so more of
stages,
these power stages. You mentioned cylinders of cars, so more power stages is more horsepower. If you're thinking
more
of it in car
horsepower. That's
terms.
exactly right. That's exactly right. You can have a four-cylinder. So like the processor in your laptop, for instance, right, is like a 35-watt processor. It only needs like four cylinders, four phases. But you start getting into these AI processors, and we're talking about 50 phases, 50 cylinders, 150 cylinders, right? So it really scales with the power levels.
Okay. You mentioned the brain and controlling everything that's going on, and but what about communication? Are we doing? Does Infineon offer anything in the way of helping data centers communicate better?
Absolutely. So with our little brain, we communicate, like I mentioned, to the processor, but we also communicate to what's the base management controller. So it's this controller that kind of manages the rack, right? So we can provide telemetry information, kind of like tire pressure monitoring on your car, right? So we can tell you which tire is low pressure and what the pressure is, right? So we can do the same thing with the processors. We can tell the system which processor is running really hot, which processor is running under strain, and the system can adapt.
Okay, yeah, and I imagine all of these elements. We have a lot of car analogies here. In a car, reliability and robustness is important. I would assume the same can be said for data centers.
You caught my message, yes. These data centers are so big, right? And the number of components are just fantastic, right? So like I mentioned earlier, you know, if you got, you know, let's just pick on the AI processors. We have 240,000 AI processors. And each AI processor will have, 50 phases around it. So this scales up tremendously, the number of phases, and then you start including the CPUs. In one data center, we can have millions of power stages, these little cylinders that I talked about, these little devices. We can have hundreds of thousands of brains, digital controllers in this. And when you have these fantastically large numbers, and these are pretty harsh environments, right? Where, like I mentioned earlier, your house is running on a circuit breaker, right? So these are tiny little devices. They're optimized. They're beautiful at performing the job. Infineon has the best products, in the market.
And not biased
But
at
they,
all.
yeah, no bias at all. But they do take a beating, right? And so it's inevitable that lifetime starts to become a factor, right?
Yeah, and
And so,
since you mentioned so many of our products are in data centers, then one failure can be more than just one tiny failure, right?
correct, yeah. So one failure could be part of a parallel processing job, let's say, right? And how you manage that failure could impact your parallel processing output. So this is why we communicate with the system, right? If we see that we're starting to see some failures, the data center can shift the loads, the computational loads, away from failing systems. And if a system does fail, let's say you're banking, right? You're doing a bank transaction, a stock transaction, and you just happen to have a failure during that moment. That's loss of income. That's loss. That's reputation. There's liability involved in this. So there's some data centers that are mission critical, right, where they have to stay up all the time. So in general, right, customers really do need to think about, what is their quality, what is the reliability of these products.
Oh, sorry, I just wanted to mention, you mentioned so much in failure. Is there any way that we calculate failure rate, or can you put that into perspective?
Yeah, so we track customer returns on our products. So for instance, we have one device, right, that's currently in production, and we're crossing 1 billion products right? So 1 billion of these power stages are out in the field, running your Google, your Chrome, right? Your these applications we're using right now. And out of these billion parts, our failure rate is in parts per million, right? So right now we're 0.8 parts per million. So that means if you sell 1 million parts, you're going to get 0.8 of a device fail, right? So if you sell 10 of them, you'll get 10 million of these parts, you'll get 8 failures. So this is a very low failure rate. And then we track these failure rates over time, right? So typically, you get a lot of failure that occurs initially, early wear out. Again, the car analogy. You buy a car. Maybe you'll have a couple initial issues when you buy a car, right? That you have to work through, and it's a very low, failure rate. And then you'll drive the car for years, right? Same thing with the data center. It'll run for years, and there'll be almost no failures. And we're in that space now. And then what happens at the end of life, like with a car warranty, right? The warranties are designed or specified to the how long the car can last. And the same thing happens with our power stages, right? It's called a bathtub curve. You have initial fails, then no fails, and then eventually failures start coming in. You get one fail, 1 week, and then maybe the next month you get 2 fails, and the next month you get 3 or 4, right? And it starts to accelerate. And that's called a wear out phase. And for Infineon, we try to make sure our power stages and our systems can run at least 10 years, right, before we hit wear out.
So a really long bathtub.
Really,
That's
really
what you're
long
saying.
bathtub. And it's the same thing that you want with a car, right? So you get a car that's 10-year, 100,000-mile warranty, right? So it's
Right.
in the same type of analogy, and that's why the car analogies. Yeah.
More car analogies. We like a car analogy. So, when it comes to sustainability, we've talked in some other episodes about sustainability, energy efficiency, carbon footprint, and AI. Robustness and reliability fit into this as well. With lifetime, I guess. Are there any trends related to robustness that really address sustainability aspects?
Yeah, absolutely. In the earlier years of my career, so I've been doing, data center power for almost 30 years now, right? And in my earlier career, a data center, a rack would last maybe 2 or 3 years, and it would get upgraded. And that was kind of a sad moment in my life when I realized, okay, all my hard work is, ending up in a landfill in a couple of years. What's happened, what's evolved since then, right? As the data centers keep growing and getting bigger and bigger, what we're seeing is they're refurbishing some of these racks, and they'll do some minor upgrades, clean them up, take the dust out, right, to make sure everything's okay and healthy again, and then they'll put them back into service, but they'll put them towards less computational heavy or less speed heavy performance focused area. So a good example is if you go on Facebook and you look like 10 years ago, right? And you're looking for a picture or photo, and you can find it. And you're okay with that delay because you know that you're looking 10 years past, right? So these are typically, this information will be stored on older servers, deeper servers. And there's a big effort on trying to improve the reuse of data centers. There's a group called Open Compute Platform, and they're also trying to define the next generation data centers to be upgradable, right? So not only do you do a minor refresh, but you could actually put a brand new processor in and have enough flexibility to support a new cutting edge performance processor, right? So you don't have to sacrifice performance.
Okay, so really thinking about a modular thing, really thinking about the long-term lifetime then of data centers. Um, are there any initiatives or what does the future look like when it comes to data centers and AI?
Okay, so one of the big problems with AI is the energy consumption, like I mentioned earlier, right? So we have racks that are in the ballpark average 16 kilowatts today, going up to 125 kilowatts. and there's roadmaps going up to 300 kilowatts per rack. You multiply that times 10,000 racks, and a significant power increase. So one of the challenges is how do we develop more efficient power delivery, right? This is a task that Infineon has been leading. There are regulations that are starting to come about. The European Energy Efficiency Directive was introduced in 2014, around 2014, and it was a volunteer effort at that time where the European management was asking data centers to provide, how much energy they're consuming, how much of the energy is being used towards compute. There's rankings or gradings of how efficient a data center is. They have there's a PUE you'll see when you search on Google a little bit. It's called Power Utilization Effectiveness. So ideally, simply what it is how much power are you taking in compared to how much you converting that power to actual compute work. So ideally, it's the ratio is 1. So all the energy coming in goes towards all compute. But in reality, you got to pay for cooling of these devices. There's AC, there's inefficiencies in the power delivery network. And these are typically, in the 1.2 range. So I think it's good that government is keeping an eye on this. The U.S. is also starting to pass legislation very similar to Europe, to start tracking the efficiencies of data centers. And we're part of that.
Okay, so trying to come up with a baseline so that we can figure out how to improve from there.
Yes, yeah. And we focus on technologies and developments that keep pushing efficiency, right? How we deliver power while maintaining the robustness, right? I think this is a very good contribution to society from Infineon. We've enabled these type of AI accelerators and this power level to grow. We have been part of this ecosystem and enabling them. And now what we're trying to do is really deliver the best efficiency in the system to really maximize the energy coming in towards computational power.
Great. So really driving efficiency rather than waiting for different regulations to trickle down to us.
Correct.
So,
Yes. We're being proactive. Yes.
yeah, that's good. Well, thank you, Danny, so much for giving us an overview on robustness and AI data centers. Thanks for being here.
Thank you very much. It was a pleasure.
Great. And thank you to our listeners for participating in our We Power AI series on the podcast for engineers. We have more episodes coming, but we want to hear from you. So if you have any feedback or you want a technical deep dive on anything in particular, please write us an email at wepowerai@infineon.com. Stay tuned for more. Thanks.